Okay guys, we're going to talk about the difference, we're going to talk about sound waves. We're going to distinguish between two characteristics of sound waves. One is pitch, and the other is amplitude. Okay, so let's start by talking about how sound waves form. Sound waves are formed by vibrating matter. Okay, so for example, when we were experimenting with our instruments last week, we were able to produce sounds by using rubber bands to vibrate, like in the harmonicas we made, or in the guitars which we made. We plucked a ruler and made a sound. We blew through a straw and made a sound. What we noticed is we could change the pitch. The pitch is how high or how low the sound is. I'm going to play you a really high-pitched sound. Okay, so that's a really high-pitched sound. A lower pitch would be my voice talking right now. And an even deeper pitch would be maybe if you live with an adult male who has a deeper voice. I'm going to play you a deeper pitch. Hold on. Let's go even deeper. I don't know if you can hear that or not, but it's a deep pitch. Trust me. Okay, so when we were playing with our instruments, for example, I'm going to erase amplitude since we're only talking about pitch right now. When we were playing with the straw, we started with a longer straw, right? What happens is we blew air into it. So here's us blowing air. So we produced, or we blew the air vibrated, and the straw vibrated, thus creating a compression wave, which I'm going to draw here. This is the compression part of the wave. That's where the molecules are compacted, they're closer together. You could say compressed together. Compression. Okay, couldn't fit it. Okay, do you see? Press, they're pressed together. Okay, and then this part in between, we call rarefaction. It's where the molecules are more spread apart. And this kind of forms like a wave. Rarefaction. I lost my N. The word rare, okay, that means it doesn't happen often. So you can think about these molecules as being fewer, less common in that part of the wave. Rarefaction. Okay, so when the straw was longer, we let's say, pretend, because I don't actually know, that this was the compression wave that happened in the straw. I'm drawing, okay, I'm deleting this for now because it's not even neat. Okay. Where you see the compression, I'm drawing a crest. Where you see the rarefaction, I'm drawing the trough. Trough of the wave. Crest. Oops, that's not how you spell crest. Crest of the wave. Okay? So when I redrew the wave to look like this, it helped me see the wavelength better. You remember from when we were learning about oceans that a wavelength is the distance between 2 points in a wave. Such as the crest to the crest. There's the wavelength. You could use the trough to the trough It's the same distance. You just have to use the two exact points on a wave. You could do the middle and the next middle. Okay? That could be the wavelength. All right, so the wavelength that I drew in the straw is from here to here. Let's count how many wavelengths we have. Here's one. From here to here, there's two. From here to here, there's three. From here to here, there's four. So we produced 4 wavelengths, and as you remember, a lower pitch. Now, then what we did, if you remember, is we cut the straw, made it shorter. So now we're going to still try and fit in those 4 wavelengths. So okay, so there's my compression, here's my rarefaction. I still have my 4 wavelengths. 1, 2, 3, 4, okay? But when I draw the wave so that you can see the frequency a little bit easier, you'll see that the wavelength is shorter. Well, you can tell the difference here. I mean, this wavelength is longer than this wavelength. So the wavelength translates into its frequency, okay? So a longer wavelength has a lower frequency, okay? So in this first wave here, okay, now I'm going to erase pitch so I can fit in this wave. I shouldn't have erased it to begin with. Okay, that's a terrible wave, but you can see the frequency of that one is different from the frequency down here. This one has a lower frequency because it's a longer wavelength. Now, a shorter wavelength, like this one up here, results in a high frequency. Okay, so frequency is just a fancy word for how many waves occur in a unit of time. So, for example, we can make this a unit of time. 1 second. Alright, so this would be a high frequency. Well, actually, let me redraw that because that was terrible. So I see 1, 2, 3, 4 wavelengths. So that has a pretty high frequency. This one would have a low frequency because I only see one wavelength in that unit of time. Frequency, frequent, means how often. Okay? Now, you remember from blowing in the straws that the shorter straw made a higher pitch sound and the longer straws made a lower pitch sound. Okay? So the shorter wavelength and the higher frequency results in a higher pitch. The longer wavelength and the lower frequency resulted in a lower pitch. Alright, so that's pitch. Amplitude refers to volume, how much energy Takes a lot of energy to project your voice and be loud. But it doesn't take that much energy to whisper, to have a softer voice. A wave can have the same frequency, so think about that same unit of time. Okay? It can have the same frequency, but a low amplitude. Okay, I'm trying here. The difference, these pretend that these have the same wavelength from crest to crest. They have the same wavelength. The difference between them is the height. This one has a really short height from the crest to the trough. Okay, this one has a longer height, or has a greater height, wave height. That's called amplitude. So the distance from the crest to the trough of a wave, from this point to this point, that's called amplitude. How much amplitude results to how much energy results in causes the amplitude. Okay. Let me play you some sounds now. Okay. That is definitely a high pitch. Ugh. Do not like that sound. High pitch. By the way, I'm playing it from my cell phone, so I hope you can hear it. I have my cell phone volume turned all the way up. Here it is. So we'll call that a high amplitude. Okay, now I'm going to play the same pitch, but I'm going to turn the volume down. Hope you can still hear it. So it's still the same pitch, a high pitch, but now it's a low amplitude. The wave height is smaller. Okay. Now on the contrary, I'm going to play you a low pitch. Compared to that last one, that was definitely a low pitch, a deeper sound. And believe it or not, I have the volume turned up on my phone, so let's just call it a high amplitude. Now, I'm going to play that same pitch, but turn down the volume. There it is. Though I bet you can't even hear that. It's the same low pitch, but this time at a low amplitude. Oops, amplitude. Okay? So we did this sort last Friday, but I want to quickly go over it now because those of us who were here did a good job, but there were several people absent last Friday and missed science, so I wanted to take the time to go over it now. Okay, so when we're talking about high pitch, high amplitude, it's that first sound I played. That really high sound, but also at a loud volume. Has a lot of energy. High and loud. We'll put that here. okay? The low pitch, but a high amplitude, that's that lower sound, that lower frequency, okay? A low sound, but still has a lot of energy, so it's a high amplitude. Loud and low. Okay, over here, a low pitch with a low amplitude. It's got that low sound, but a softer volume. A high pitch at a low amplitude, that's like the first sound that I played you, that really awful high pitch. Hear the pitch increase, but at a low amplitude, so we're turning the volume down. It's the same pitch, it's just at a softer volume. Soft. Okay, now let's look at these waves here. Notice how this wave, this wave, this wave, and this wave, two things are changing. First, the wavelength is changing. Let's go ahead and zoom in here, because I really want you to see what I mean. Okay, so here's the two things that are changing. The wavelength is changing. So the distance from one point on a wave to the other point on the next wave. So from crest to crest, there's the wavelength. Notice it's the exact same wavelength up here from crest to crest. These two waves, which I just drew on, have the same wavelength. Now over here, the one that's labeled B, this has a shorter wavelength. This one down here, it has that same short wavelength. The other thing that's different about them is the height, the amplitude. These top two, this one, this difference from the crest to the trough, that has a greater amplitude. It's a taller wave. D has the same amplitude. These two ones down here have a less amplitude. The height is shorter, so to speak. Okay, so now that we've noticed that, we can sort where they go. B right here has a shorter wavelength, which means a higher pitch, but a high amplitude. Or I said shorter pitch. A shorter wavelength, a higher pitch, higher amplitude. Sorry. It's hard to it's hard to talk and operate my iPad and computer at the same time. So notice how the wavelength is short, which results in a higher frequency and a higher pitch, and the height is showing a lot of energy and a higher amplitude. This one, D, this one still has that high amplitude, that high volume, but the wavelength is longer, which results in a lower pitch. The difference between these two is the pitch. This one's a low pitch. Sorry. This one's a low pitch. This one's a high pitch. But the amplitude is the same. Okay? Down here, both of these have a a shorter wave height. So the amplitude is lower. This one has a low amplitude. Oops. Yeah. But the wavelength is shorter, resulting in a higher frequency and a higher pitch. This one down here has a longer wavelength, therefore a lower pitch, but the amplitude is the same. You can kind of see that if I were to move this. Now you can kind of compare them. They have the same height, wave height, the same amplitude, but the difference is the frequency. Okay, these two are showing sound waves as they actually exist, compression waves. You can't really tell the amplitude, but you can see the one with the higher frequency. This one has a higher frequency and therefore a higher pitch. This one has a lower frequency and therefore a lower pitch. So when we did this in class, I said you can sort them in either. This one has the higher pitch, so I can put it here. This one has the lower pitch, so I can put it here. But we really can't derive the amplitude from those drawings. Okay, so that's the difference between pitch and amplitude. An easy way to just remember it is pitch is how high or how low. Amplitude, volume. All right. Thanks for paying attention.